Hello everyone, my name is Hisham, the owner of Clemson Aeronautics, where we make the riveting and dimpling systems. Today we have the task of countersinking the rear spar on the left elevator where the hinge is for the trim tab. There is a few things that we have to watch out for. I clecoed the hinge pin to the rear spar in the area where it's supposed to be countersunk, and I had dimpled everything else. Now, if I managed to set this in a drill press, I have to set it where this surface here is flat. And of course, as you know, this the flanges are bent in a little bit to match the profile of the elevator. So in order to do that, I have to build a fixture to hold it. And the reason have it is, let's say I made a fixture where when I set it against it this way, for instance, this is flat here. Let's say I did that. This is going to be flopping. The hinge pin itself will be flopping. So while I'm countersinking, the countersink itself will push the hinge away. So it will not be like countersunk correctly. So I decided to make a fixture where it actually goes in here, and the inside part here would be rested on it. So when I use my drill press, it will press on both the outer part, which is the rear spar itself, and the hinge at the same time and squeeze them together. Then the cutter will go in there and do its job. So this is what I'm attempting right now, and I'm thinking about it as I am filming this right now. And I made it where I leave 6 holes exposed, but it's lined up enough with enough clecos. The last one have only 5 holes, but the idea is to cut something out of this wood block where this would go in between the clecos, and there's a groove for this part of the hinge pin to sink in, but it will be supported from the other side, from inside here. And once I make this block, I want to screw it to this block here and take them and put them in the drill press and put this in here, and I would countersink them and then move it and then countersink them and so on. In order to do that, I have to shape this block with this shape inside. So I took the rear spar of the right elevator to use because it doesn't have anything mounted to it, and I just want the profile here. And I put it where this part is flat with this part, like this. I don't know if you can see it properly or not, but I put it outside a little bit, like this, and it's flat with it. And I took my marker and I marked on the wood, and now we will assume that this mark is correct, and it goes right to the corner here. You can see that from the corner. So I want to remove this wood right here, and I want to remove the part that from the inside and maybe a little bit more to go all the way here, and I want to cut right here like this. How am I gonna do this? Not quite sure yet. I'll figure it out and I'll let you guys know. I'm letting you think with me, so when or if you decide you are going to make a fixture like this, you see my thought process and how I built it, so you can build one for yourself out of a 30-cent piece of wood. I managed to cut the angle here after I drew it, and the way to position it on this saw here, I just picked something that I have. When I put it like this, it creates that same angle that I want to achieve, and I just positioned this here in a certain position. Then I cut it very slowly right on the edge. Then I took it over to the belt sander and smoothed this, because it will give you a sharp corner here, and there's a radius inside that rear spar. So I sanded this down radius here, and as you can tell, I got very close to the line right here. Right now I need to move this material here so the rear spar would fit inside here. So, and the opening obviously is very small, so I have to go straight this way. So I'm thinking about putting it on my miter saw. My miter saw moves this way. I'm just gonna make my mark, and I will nail this to something so I don't have my hand so close. And I'm just gonna use the miter saw going back and forward at the same height to remove this material. Well, you've seen me how I drew on the wood using the rear spar and the marker, and then went on the saw and did all of that stuff. Of course, there's another way to do it. You just put the spar end on a piece of paper, and you just mark it from the inside. Make a nice mark, and then you have the shape. You can cut the little piece with the scissors and then put it on the wood to mark it, and then go on to the saw to do it. Of course, if John Wayne was building an RV-14, he wouldn't be marking on paper and using scissors and stuff like that. But it's up to you how you want to do it. Another thing just to mention real quick, now if you are gonna be really picky and you're gonna get all kinds of equipment and stuff to get it down to the degree, you can go to the page 9-12 and it will tell you that this is 96 degrees. So it's bent in 6 degrees, so you can get all kinds of stuff and mark 6 degrees and you can cut the wood. It's not worth your time to do that. Okay, after playing with my all kinds of different saws in all kinds of different ways, I managed to get this profile where there is a groove here. And the reason we have a groove here is because it will go in and the hinge will go inside that groove, and this would be level. So I'm gonna screw this to another flat plate so I can put it on the drill press. And the plan is, like, I'll have it on the drill press. This is nice and level here now. I'm gonna countersink these holes, then I'll take it out and put it in the next one and do the other 6 holes and so on, then remove the clecos and do the rest. One note though, we have to be careful with. I just noticed that I have not deburred that hinge pin or that hinge. So I need, if there is a burr, it will make it stand out from the rear spar from underneath, and I can see a burr right here. So I'm gonna deburr that really nice so it will be sitting nice and flush inside the rear spar while I'm doing the countersinking. Okay, the fixtures that I made to hold the rear spar and the left elevator worked out really well, and that groove where the hinge goes in clears it out pretty good, and this is pretty level with the drill press. I already set it up and I tested it out and it works really well. I countersink my test hole in the real piece here, not this one, just in case if I messed up. Of course I checked it on something else first, and I will get to that, but I decided I'm gonna go in about hole number 5 just in case it didn't go as well as I wanted to. It's an inner hole where I can put a bigger rivet or do something about it, not the one on the end. Now, when I was testing the setup that I had, I put my chamfer tool in there, and identical to this one, except this one is just cut off for a different reason, of course. And I set it up where I thought it would be a good depth for it, or just a starter depth. And I took a thicker piece of aluminum and I drilled a 0.96 hole in it, and I tested it out, and of course it's shallow, and you keep on. Okay, when you go down with the drill press, the bit goes down, so this stays where it is and this goes down. So the way to adjust it, you unscrew the nut that's on top. This part spring loads, and if you can see the teeth on this thing, so every tooth, when you turn it in or turn it out, every tooth is 1/1000th of an inch. So I keep on going in, going in, going in, and every time I go in, I engage the teeth and lock the nut and test the piece till I got my rivet to go in flush, perfectly flush. Then Van's manual tell you you need to go 7/1000 deeper. That means I will undo this nut right here, pull this up, then go 7 teeth. That's why if you look at the other chamfer tool that I have, or a countersink tool that I have set up in the machine, I put tape on top, on the bottom one and on the top one, and I marked with my marker on every tooth so I can count easily each one. And I went in, so when I go in this way, that means it goes deeper. If I screw it outside, it goes shallower. So I went in deeper 7/1000, and I tested my piece, and I had a little thing just to make sure, which is just a little piece of aluminum that I drilled and dimpled, and simulating the skin of the elevator, and I put it on the hole that I tested with, and I put a rivet in there, and I would hold it like this, and I got a piece of paper. This piece of paper is 4/1000 thick, so when I go in, it will go in, but not a whole lot. Okay, if it goes all the way to the end, it's okay, but it needs to be just barely going in there. And that's what Vans said to do. I called them up on that months ago. And they said, we'd rather have it where the skin just a little bit higher than go deeper and mess up everything. Structurally, it will be engaged, like the rivet itself will be engaged in most inside the dimple holding the two parts together. So I'm going with what Van said about this one, and I set up my drill press to continue countersinking my rear spar. I did the first 6, and they look pretty good. They're all consistent. The tool is doing a good job, but it's building up chips around the tool itself. So I will have to stop more often than I thought I will, just to clear the chips out of the tool and make sure it doesn't get in between the two surfaces here, because we're literally chamfering the first surface, which is the spar itself, and also chamfering the hinge. So we have to make sure that there is no chips in between every time we start to countersink each hole. I'm sorry, chamfer is kind of a machinist term to create that countersink. So I'm gonna go ahead and finish the rest of the spar, and I'll be back with you to conclude this video. I am done with countersinking my left elevator rear spar with the hinge, and it worked out great. The countersinking part took a lot less time than making the fixture itself, but the benefits of taking the trouble to make the fixture far exceeds the time that I spent, because of the consistency that I got. I had a cleco on the first hole and the last hole, then I was leaving 6 open, then a cleco, 6 open, then a cleco, then 5 open. And my fixture would fit right between the clecos when they were like that, in that sequence. And very simply, there's a hole here that was not countersunk because the cleco was there. I just moved that one cleco and I put it in there and put it back in the fixture, and I countersunk it, and I've done that same thing. Now the last one at the end, I didn't know what to do. There was just long ways that was not clickoed. So what I done is I put it inside. I put the Clicko inside one of the holes. I made the hole bigger so the Clicko would go in there, so it would align it perfectly. And I countersink it. And the same thing when it came in to the Clicko on the right. I put like a number 30 hole in there just to clear the Clicko itself, and I put it in there and made sure it's aligned and everything, because you can put a Clicko in there and after you put it and you look at the holes and the hinge is not lined up, the holes are not lining up anymore because the Clicko doesn't really center it, so you have to work on it to make sure it's centered before you start countersinking or drilling. So but it worked out really good. I finished all the countersink holes, and it matched pretty good. Yepper. So all we have to do now for those is make sure it is deburred, and just so you can get an idea also, the hole now in this part is bigger because you actually went with the countersink all the way into the hinge itself. So now the hinge doesn't need deburring, but this became very sharp. I would take a Scotch-Brite to it before I paint it. So that is what I'm going to do. This is it for this video, folks, and I hope you enjoyed it and I hope you benefit from it. I say it was worth the time to do that fixture to after all this hard work, I get a consistent rudder. And thank you very much for watching. And please do click the like. If you do like the video, please click the like button. And if you're not subscribed, please do subscribe. Thank you for watching, and we'll see you next time.